Okay, so the next conic section is hyperbolas. We did circles and ellipses and parabolas. Okay, so the hyperbolas are the last ones. You can think of a hyperbola as kind of like a circle that's been split open down the center. Okay, but by definition, it's a set of all points such that the difference in the distance from the point to two fixed points called foci is constant. Okay, so the difference is constant instead of the sum being constant like an ellipse. Okay, so with a hyperbola, you have two branches. Okay, they can go opening left and right, or they can open up and down. Oops. So, like this. And then these branches keep going, so to speak, but opening up and down or left and right. Okay. The foci are inside the branches. So when you look at the graphs, right, the foci would be like here and here. Okay. So when you have a point on the hyperbola, this would be one distance, this would be another distance. And we're talking about the difference between those two distances being a constant for all points. Okay. So you have your foci, and then, which are these, okay, and they're inside the branches of the hyperbola. The line that goes through the two foci is also going to intersect your hyperbola in 2 points. And where it intersects the hyperbola in 2 points are called the vertices. So you have a vertex on each branch. Okay. And then halfway between the two vertices is the center. I'll put the center here. Okay, and the line that passes through the two vertices is called the transverse axis. Midpoint of the transverse axis is the center, okay, or halfway between the two vertices. These two branches are identical, and they also contain two asymptotes. Then the asymptotes are the diagonals of a rectangle that's centered at the hyperbola's center. Okay, so then it has a rectangle coming up like this, or on the up and down, and then the diagonals there would be the asymptotes for the hyperbolas. So how you decide how wide the hyperbola is those asymptotes. Okay. When you look at the equation of a hyperbola, okay, it is very, very similar to the equation of an ellipse. But this constant is a difference. So that's how you tell the difference between it being a hyperbola or an ellipse. Okay? For hyperbolas, it's x squared over a squared minus y squared over b squared equals 1. Or you can flip it, and you're going to flip the x and y this time. So it's going to be y squared over a squared minus x squared over b squared equals 1. Okay, so when the x term is positive, that's the one that opens left or right, or left and right. It also has a horizontal transverse axis. Okay, when y squared is positive, right, so it's y squared minus x squared, that one opens up and down, and then it has a vertical transverse axis. Okay, then your value of A is going to tell you where your vertices are. So A is the distance from the center to the vertex. Right, and that's the key, is knowing that that's what A actually represents. So when the center is at 0, 0, then your vertices are at plus or minus A, 0. And then for ones that open up and down, the vertices are at 0, plus or minus A. Okay, the key here is to know this is the distance from the center to a vertex. And then because a hyperbola has asymptotes, that's where the value of B comes in. So you're going to find your vertices, and then B is going to tell you the other dimension of your box or your rectangle, okay? So your asymptotes here are the equations y equals plus or minus b over a times x, and then for these, it's y equals plus or minus a over b times x. So A is one dimension of the rectangle, and then B is the other, and then you can get your asymptotes from there to make your graph. Okay? All right, so how do we graph a hyperbola? All right. All right. Oh, and then the foci, because the equation has a subtraction, and the foci has to be inside the arms or the branches of your hyperbola. The foci is c units from the center, and you use c squared equals a squared plus b squared this time, instead of minus b squared. Okay? All right. So we're going to graph 9x squared minus 16y squared equals 144. Okay? So we know it's a hyperbola because there's subtraction between the x and the y squared terms. So we have to put it in standard form first. To do that, you need to get it equal to 1. So we're going to divide by whatever this number is. So divide by 144, 144, and 144. Okay? So then in standard form, our graph is x squared over 16 minus y squared over 9 equals 1. Okay, so that's what we're going to graph. All right. So here is our coordinate plane. Okay. So the very first thing we need to do is we need to decide which way this is going to open. Okay? We look here, x is positive, y is being subtracted. So it tells us it opens left and right. Okay, so we have a horizontal axis. Our center is at 0, 0. Then we're going to find our values for A and B. So the first one on a hyperbola is always a squared. So a squared is 16, so a is 4. B squared is 9, So b is 3. And then you can find your foci, right? So c squared equals a squared plus b squared. So 16 plus 9. So we get 5 for C, for the foci. Okay, so if A is 4, that tells us our vertices are 4 units from the center and horizontally. So here's the center. So 1, 2, 3, 4. And 1, 2, 3, 4. Okay, if it was vertically, we would count up and down. Then, so that's our transverse axis. So our hyperbolas are going to go this way. We want to know how steep they are. So that's where B comes in. Okay, so from the center, we're going to go up B units to get our rectangle. So the rectangle that we want the asymptotes for is here. So then we know how wide the hyperbola is going to be, okay? Because asymptotes are lines that our graphs get really, really close to but never touch. So getting closer to those diagonals, and we get our hyperbola. The black and the curves are the hyperbola. These are just the asymptotes to help us guide it, so we don't have to pick points, because that gets a little more challenging with a hyperbola than other graphs. Okay? So decide which way it opens, the center, where your vertices are, then the other dimension of the rectangle, and then for us, our foci would be here and here. And we could say that the asymptotes are y equals plus or minus rise over run, right? So rise over run. So plus or minus b over a x. Okay? All right. Then we can use information about our hyperbola to write the equation of one. All right, we know we have foci at 0, 5 and at 0, negative 5. And we have vertices at 0, 3 and 0, negative 3. Okay, so if we were to think about where these are, right, because we know the transverse axis goes through the foci and the vertices. So 0, 5 and 0, 3. So that tells us it's a vertical transverse axis. So that tells us it's going to be y squared minus x squared. Then we just have to figure out a and b. Okay, so the center's at 0, 0 because it's equidistant between the vertices. And a is the distance from center to vertex. So from 0, 0 to 0, 3 is 3 units. So a is 3, which means a squared is 9. So we get y squared over 9. Okay, then we need to find b, because that's our other coordinate, right? So we're going to use our foci. It tells us that c squared equals a squared plus b squared. So we want to find b, because we know a. So b squared is going to be a squared minus c squared. So, not a squared, c squared minus a squared, because c is going to be longer than a in this for hyperbolas. Okay, so then c is the distance from the center to a focus. Okay, So the focus is 5 units from the center, so c squared is 25. All right, and 25 minus 9 is 16. So b squared equals 16, b would be 4. So we said b squared is 16, so we get y squared over 9 minus x squared over 16 equals 1. That's another difference with the hyperbola. A and B are not, A is not always bigger than B. Okay, it just tells you the distance from the center to the vertex. And then this tells us the other dimension of the rectangle to get our asymptotes. Okay, so that's hyperbolas.